Hey, welcome back to Road to Data Engineer. This is going to be episode 20, and we're picking up where we left off on the Shells and Terminals course on Boot.Dev. I believe we're about to start getting into learning about the path a little bit more in depth. Okay, so let's get started. Okay, so let's see here. Okay. First, restart your shell session to reset your path variable to its default. We just opened it, so it should be good there. You can do that by closing your terminal window and opening a new one. A common problem you'll run into in the future is that you'll install a new program on your machine, but when you try to run it from your terminal, you get an error like command not found. 9 times out of 10, this is because the program is installed in a location that's not in your path variable. I've experienced that at work. Oftentimes, when you install a program using the CLI, it will print a message during the installation process that tells you where the command was installed. Don't let your eyes glaze over when your terminal prints important messages. Sometimes you just gotta RTFM. What does that mean? RTFM or RTFM abbreviation. Read the fucking manual. That's funny. Okay. The World Bank directory that you downloaded has some executables that would be useful to have in your path so that you can run them from anywhere. Add the World Bank private bin directory to your path variable. You'll need to add the absolute path, not the relative path. You can get the absolute path by running pwd in the World Bank private bin directory or by using the real path command. To add a directory to your path without overwriting all the existing directories, use the export command and reference the existing path variable. Interesting. Okay, let's look at my notes real quick. To display, export var name. To add a directory to your path without overwriting its contents. Export path equals path colon path to new equals path colon new directory colon. Yep. The path part is a reference to the existing path variable. Yep. So we need a $sign. The colon separates existing directories from new directory path to new that you're adding. Once you've done that, the CD outside the World Bank directory entirely may be to your home directory. You'll need to add the absolute path, not the relative path. You can get the absolute path by running pwd or by using the real path command. Real CD World Bank private bin or real path. I don't know, this real path command is not working. Okay. So we have the absolute path, and then I want to set my path variable, export path equals path variable new directory. But I need to do this. And there we go. We see it's right at the end. Now we're going to cd to the root. Grant, yep. Then try running the world bank.shcli tool. Follow the prompts and copy paste the entire interaction with the tool into the input field and submit your answer. Starting with welcome and ending with goodbye. World bank.sh. Welcome to World Bank CLI tool. Please enter your name, Grant. I wonder if it's going to actually email. I'm not sure. Maybe? Gonna do this part off screen briefly. I'm not trying to post my public email. Okay. Okay, interesting. Okay. Well, it looks like that didn't matter anyways because they're not actually going to do anything with my email. That's fine. Okay, so got through that section. Okay. Let's go back to PC screen only. Okay. All right, in the last lesson, you changed your path variable for your current shell session. Trouble is, the next time you restart your shell, it will be reset to the default value. You won't be able to use the CLI tool from anywhere unless you change your path variable permanently. The most common way to do this is to add the same export command that you used in the last lesson to your shell's config file. Edit your zhsrc/bash/rc file, whatever your shell config file is, and add an export command to the end of the file that adds the world bank directory to your path variable. Once you've done that, restart your shell session. To permanently change your path variable, you have to update your shell config file. Your shell's config file. Adding something like export path equals path new directory to the config file. In this case, the config, you have to update. The config file is .bashrc, and you can add the command at the end of the file. Okay, that makes sense. So let's do a couple things. Let's go to the root and open the config file. What was that way we showed even invisible files? To list, A. Maybe it was in my home directory. Trying to see. Oh, it is in my home directory. So .bashrc. How do I open the file? .bashrc. Permission denied. The fuck? Maybe I need to do sudo .bashrc. Command not found. Weird. Okay, well, we'll just go into it like this, I suppose. Home grant bashrc. Uses a host unless you trust the host. Export path equals path, and then what was the directory we wanted to add to it? World Bank private in cd absolute path. File save. So now if I restart the shell, I should be able to what? Equals not a valid identifier. What? The fuck? Oh, maybe because I have spaces? Okay, there we go. Nice. And now we should be able to execute right off the bat. Boom. What changed when you added the path? Changed your file. We need to use the full path to the World Bank. The World Bank is available from anywhere, even after a session restart. Boom. Money. The man command is short for manual. It's a program that displays the manual for other programs. I know that manuals and documentation can feel intimidating. Heck, that's why there are courses like this one to give you a gentler introduction. That said, manuals and documentation should become more useful to you as you become a more experienced dev. They're not as scary as they seem when you actually take time to read them. Using man. The man command will only work for programs that it has a manual for, but most built-in commands and Unix programs are supported. You just pass the name of the command you want to read the manual of as an argument. The most intuitive place to start of course, is reading the manual. Okay. Man. Whoa. Name, man, an interface to the system reference manual. Synopsis. Option, section page. What options? Page, file. Description. Man is the system's manual pager. Each page argument given to man is normally the name of a program. The table below shows the section numbers of the manual followed by the type of pages they contain. Most people don't read manuals for fun. More often than not, the manual is used to reference, to quickly look up usage or special flags. You can search for the text in this manual by pressing the / key and typing your search, then pressing enter. Let's try to look up what the R flag does for the ls command. Okay, let's take some notes. To open the manual for a command or program. Man, command, or program name. Type /R. Press N to jump to the next result. Press N to go back if you went too far. Man ls /R. Press N. N. Interesting. When you are inside a manual, you can search for text using blank /R /text string /text to search for. In key will jump you to the next result, and in key will jump you to the previous result. Okay. So let's actually look at this real quick. So man ls description, list information, mandatory arguments to long options are mandatory for short options. Do not ignore entries starting with. Do not list implied. With L, print the author of each file. Oh, interesting. So slash R, reverse order while sorting, recursive, print the allocated size, sort by file size. Nice. Interesting. As a system person, the grep command is going to be your best friend and has a lot of power, but it can be a little confusing to use. Open the manual. You'll notice that the manual is an interactive session. You can page through the manual with the spacebar and quit with Q. Read the first couple paragraphs of the grep manual and answer the questions. Okay. Man grep. Synopsis. Grep searches for patterns in each file. Patterns is one or more patterns separated by new line characters. And grep prints each line that matches a pattern. Typically, patterns should be quoted when grep is used in a shell command. A file of dash stands for standard input. If no file is given, recursive searches examine the working directory, and non-recursive searches read standard input. In addition, the variant programs egrep, fgrep, rgrep are the same as grep e, grep f, and grep r, respectively. The variants are depreciated but are provided for backward compatibility. Interesting. V, version, output the version number of grep and exit. /v. Pattern. Patterns is extended regular expressions. Interpret patterns as fixed strings. Interpret patterns as basic regular expressions. Plural. Matching control. Invert match. Invert the sense of matching to select non-matching lines. Selects non-matching lines. Interesting. Okay. Which option is incorrect? C, count. Let's search it for it. T. R, difference, recursive, okay. Go to the top. We're gonna search for I, ignore case. Okay. We're gonna search for, C. C, count. Suppress normal output, instead print account matching lines for each input file. Flags. As you've already seen in this course, some commands can take flags. Flags are options that you can pass to a command to change its behavior. Yep. For example, ls command can take L flag to show long listing of files. Ls command can also take A flag to show all files, including hidden files. You can combine flags. Interesting. So we have ls. Okay. Interesting. Whether or not command takes flags, and what those flags are is up to the developer of the command. That said, there are common conventions. Single character flags are prefixed with a single dash. Multi-character flags are prefixed with 2 dashes. Sometimes the same flag can be used with a single dash or 2 dashes. You found that some files have been tampered with. To figure out which one it is, you need to know the number of bytes contained in each file. Use the word count command to count the number of bytes in the World Bank PRIDs files. Use the man command to figure out which flag you need to use. That's pretty sick. Okay. Paste the number of bytes, just the number, into the input and submit your answer. Okay. So let's do cd World Bank public PR ideas. Okay. I'm just gonna do PR ideas off the rip. PR IDs. Count the number of bytes in the World Bank ideas text. WC bytes. I'll print the byte count. Oh, there you go. It's pretty much right there. WC C PR ideas dot text 1098. Did not copy. Submit. Boom. We're cooking. We are cooking. Positional arguments. Programming languages have functions, and functions take arguments. For example, this Python function takes 2 arguments, xb and print player. Print player has xb. Xb is level. Yep, in shell commands, programs can also take arguments. For example, the cd command takes a single argument directory to change to. Other commands might take multiple arguments. For example, the move command takes 2 arguments, the file and the destination. Take a look inside the World Bank public directory. Cat the contents of the suspicious looking key.txt file. This looks like some kind of private key. Why is it in the public directory? Cat key.txt. Begin RSA private key. Okay. When you're done, list the contents. Move it from the World Bank to private. Move key.txt to home World Bank private. Did it work? I think that did work. When you're done, list the contents of the World Bank private directory. Paste the output, input field, and submit it. Money. There we go. Nice. By convention, most production-ready CLI tools have a help option that will print out some information about how to use a tool. It's usually accessed with one of the following. Whoa, that's a lot. Let's try the other one. The help output is often easier to parse than a full man page. It's usually more of a quick start guide than a full manual assignment. You need to make some network requests as part of this audit. You want to make sure that this machine you're auditing only has access to authorized systems. To make those requests, you'll need to know how to use curl. It's a CLI tool that lets you make network requests from the command line. Print out the help menu for curl. So I'm gonna guess it's curl and then I have the help flag. Boom! What if I do curl help? Okay, or curl help. Print out the help menu for curl. Data, fail silently, get help for commands. Output file. Upload file, transfer local file to destination. Make the operator more talkative, show version number, and quit. Okay. Wait. Paste the command you use to print the menu. Not the menu itself in the field. Okay. Well, I clearly need to learn how to read. Exit codes, sometimes called return codes or status codes, are how programs communicate back whether they ran successfully or not. 0 is an exit code for success. Any other exit code is an error. 9 times out of 10, if a non-zero exit code is returned, meaning error will be run 1, which is the catch-all error code. Programs that call other programs use error codes to figure out if execution was successful. For example, if the Boot.Dev server program exits with a non-zero exit code, we have another program that will automatically restart it and log the error. In a shell, you can access the exit code of the last program you ran with the question mark variable. For example, if you run a program that exits with a non-zero exit code, you can see what it was with the echo command. Fuck, I fucked it up. I don't understand how some of that works sometimes. Oh, okay, well, that did not work clearly. Okay, anyways, ls. Okay. Echo 0. ls false directory. Okay. Echo 2. Okay. Commands will usually exit with error codes. They've been run without the proper arguments or configuration. For example, the private bin warn sh script will exit with a non-zero code if you don't have the required environment variable set. Run the warn.sh script without setting the 2 environment variables warn message, warn from name that it requires. Run the echo command to see the exit code, paste the exit code in the text box and submit your answer. Okay. Error code of 69. Tips. You can use the unset command to unset an environment variable Alternatively, you can set the environment variable to an empty string. Okay. Standard output. Standard output, usually called standard out or std out, is the default place where programs print their output. It's just a stream of data that points to your terminal, but we'll talk later about how it can be redirected to other places. All programming languages have a simple way to print to std out. In Python, it's the print function. In a shell, it's the echo command. Okay, that all makes sense. Assignment. Use the grep command to print all the lines in World Bank Private Transactions 2020 CSV file that contain the word Marshall to stand out. Copy the output into the input field and submit your answer. Ooh, okay, I need to review the grep command. Grep string example file. Okay. So I want to say Marshall, and then I want to do World Bank Private Transactions 2020.csv. Okay. Nice. Standard error. Standard error, usually called stderr, is the same thing as standard output, but for error messages. It's a stream of completely separate from standard out, so that you can redirect it to a different place if need be, but by default it prints your terminal just like stand out. Redirecting streams. You can redirect stand out and stand error to different places using the greater than and greater than 2 operators. Greater than redirects stand out and greater than 2 redirects standard error. Redirect stand out to a file. Okay. Redirect standard error to a file. Interesting. We're gonna go back to my home directory. We're gonna say echo hello world, and we're redirecting the standard out to hello text. And there we go, it created the hello text. We're gonna say cat example file.txt to error.text. Cat error.text. Oh, okay. Cat hello.text. Okay, I see. Assignment. There is a process transaction sh script in the World Bank private bin directory. It accepts a path to a transaction CSV as a positional argument. There's a process transaction script in the World Bank. It accepts a path. Oh, sorry, excuse me. I'm kind of exhausted today. See, to a transaction CSV file as a positional argument. It prints modern transactions after the year 2000 to standard out animal transaction to standard error. Run the script and pass it the path to the 2020 CSV file in the World Bank private transactions directory. Be sure to redirect standard error to a temporary file called temp World Bank log. Next cat temp World Bank log file to see the old transactions, then paste the output in the input field and submit your answer. Okay. So we're going to do process transactions.sh. Path file. Script in the World Bank private directory. It accepts a path to a transaction CSV file as a positional argument. Okay, I see that here. Be sure to redirect standard error to a temporary file called. Okay. So path to file is going to be World Bank /private /transaction /2020.csv. Okay. And I need to say say blank or greater than or 2 greater than 2 /temp /worldbank.log. I don't know if that worked. CD World Bank private transactions. Oh, maybe I went too far. Oh, here's temp. CD temp. World Bank log. Oh, there we go. Cat temp World Bank. Oh, okay, I see. It's literally giving you the command to access the file from the root. Okay, well, I understand now at least. Okay. Nice. If there's a standard output, there must be a standard input, right? Standard input, usually called standard in or stdin, is the default place where programs read their input. It's just a stream of data that programs can read from as they run. All programming languages have a simple way to read from standard in. In Python, it's input function. Name, input, what is your name? Hello, name, hello, Wayne. Assignment. Run the World Bank private bin World Bank sh program again. Notice that it makes use of standard in to read your name and email. CD, CD. World Bank sh. Please enter your name, Sharon. KK@gmail.com. Take a closer look at the code in World Bank sh file. What command does it use? Okay, let's try to read the command. CD private CD and CD ls cat World Bank sh. Read. That's the command. Nice. Nice, nice, nice. Piping. I think we're gonna go to 20, and then I think I'm going to bed early tonight. One of the most beautiful things about the shell is that you can pipe the output of one program into the input of another program. With this one simple concept, you can run incredibly powerful automation tools. Pipe. Okay, we're gonna write this part down. Piping. A pipe operator is the character that looks like a vertical line. It's usually on the same key as the backslash above the enter key. The pipe operator takes the standard out of the program on the left and pipes it to the standard in on the right. Blank is the pipe operator. There we go. The pipe operator takes the standard out of the program on the left and pipes it into the standard in of the program on the right. Echo, have you heard of the tragedy of Darth Plagueis the Wise? WCW. Now, what does WC do again? We might be about to use the man here. Okay, yeah, let's look it up. Man WC. Print new line, word, and byte counts for each file. And we're going to do slash words. Print the word counts. Okay. So we're going to say echo how many words are in this string. wc dev. Hey, that's pretty sick, actually. That's pretty sick. In this example above code, however, instead of that text being sent to your terminal, the pipe operator pipes it into the WC command. The WC command counts the number of words in the input it receives, and the W flag tells WC to only count words. This only works because the WC command, like most shell commands, can optionally read from the standard instead of the file path. Assignment. We need to figure out just how many transactions Bob has been involved in. Bob's looking sus for real. Use the grep command to find all lines in all of the transactions that include the word Bob. You'll want to include all of the files in the World Bank private transactions directory, but not the files. Then pipe the output of that command into WCL command to count the number of lines. Okay. WCL. Oh. Path to transactions directory. World Bank private transactions 3973. Man, that's a lot. That is pretty sus. But the piping is pretty cool. Interrupt. Sometimes a program will get stuck and you'll want to stop it. Common reasons for this are you made a typo in the command and it's not doing what you want. It's trying to access the internet, but you're not connected. It's processing too much data. There's a bug in a program causing it to hang. In these cases, you can stop the program by pressing Control-C. This sends a SIG-int signal to the program, which tells it to stop. Control plus C is the interrupt command. Inside the World Bank private bin directory, there's a program called malicious.sh. Sounds scary. As a good security auditor, and knowing that you're on a secure system with no internet access, you want to see what this program does, go ahead and run it. It will run forever if you let it. Use Control-C to send a signal to the program and stop it. Paste the last line of its output into the input box and submit your answer. Okay. Malicious.sh. Doing scary stuff. That's funny. Malicious skullduggery complete. Okay, okay. That's funny. Okay. Okay. We're just going to finish this chapter 4. There's not that much more to go. There's only a few things. Kill. Sometimes a program is in such a bad state or is so malicious that it doesn't respond to the signal, in which case the best option is to use another shell session. New terminal window to manually kill the program. Sometimes you will need to kill a program when the interrupt command does not work. To do this, open a new terminal and enter the following command. Kill PID. PID stands for process ID. Every process that's running on your machine has a unique ID. The PS process status command can be used to list the process running on your machine and their IDs. Interesting. PS aux. Interesting. The aux option just means show all processes, including those owned by other users, and show extra information about each process. That's pretty interesting. To list the processes running on your computer. That's pretty cool. PS aux. PS aux. Assignment. You did some digging and found out that the malicious program actually has another mode of force. Run the program again in force mode. Okay. Malicious.sh force. You can't stop me. That's so funny. That's mad funny. It won't open a second terminal window. Pipe the output of PS aux into grep. Interesting. That's weird. PS aux time command. I want to see if I can actually snap views root PID interesting. Pipe the PS aux output into grep for malicious sh. That makes sense. You'll probably get 2 results. You don't want to accidentally kill a system critical process. Yeah, that would be pretty bad. Let's look at the grep command again real quick. Grep Colorado force, and then PID kill once you have the PID, it should just be a number. Kill it. Kill PID. Copy the line that was printed in a terminal when trying to kill the mission. Paste it in the input field. Don't paste the result of the kill command. Kill. Kill PID 19577. Oh, there we go. It worked. Okay, it did work. PID is the argument for process ID. Tip, run psaux. Wait, copy. Tip, run psaux head in. Want to see the header row of the psaux table. Let's try to understand that command though. So psaux shows us all the processes running. Now let's pipe that into the head command. The first line. Oh, okay. User PIDC. Nice. That makes sense. Unix philosophy. The Unix philosophy is a simple set of principles that have guided development of Unix operating systems for decades. It can be summarized as write programs that do one thing and do it well, write programs that work together, write programs to handle text streams, because that is a universal interface. This is why programs like lsgrep less exist. They do one thing and they do it well. They don't try to do too much. Write programs to work together. Because at least according to Unix philosophy, programs should do one thing and do it well. It's easy to write programs that work together. For example, you can use grep to search for text in a file and then pipe the output of grep into less to display the results interactively. Write programs to handle text streams because that is a universal interface. This point is more the how of the previous point. Programs work together easily when they all use the same interface, text streams. A text stream is just a sequence of characters that can be read or written sequentially. In other words, a text stream is just text. Yep. This harkens back to the point we talked about at the beginning of this course. The shell is a command line text interface. Text-based interfaces are much more powerful and extensible than graphical interfaces. That's why developers have been using them for decades and why what we can do with them looks like magic to the uninitiated. Okay. which is the more powerful interface, at least from an extensibility and interoperability standpoint. I don't even know what this word means. Interoperability. Let's look it up. The ability of computer systems or softwares to exchange and make use of information.
Interoperability.
Oh, interoperability. That makes sense. Nice. Okay, so we finished the programs chapter. I'm honestly really exhausted tonight, so I think I'm going to call it here. In the next episode, we'll work through this packages chapter. It doesn't have too many lessons, so maybe it won't take too long. I'm not sure. We'll see. Looks like it's getting into some IDEs. So I'm not really sure what to expect, but we'll try to get through these in the next episode. And then after that, we'll get back to working on the second web scraper file for the side project. So to anybody who watched, thanks so much for joining me this evening. I hope you had a wonderful day and you have a wonderful evening, and I'll see you soon.